How's it going? All right. I'm sad that you are watching this because that might mean that you missed class for this lesson. And this is kind of a biggie lesson, mostly because it has some real life application that I want you to be familiar with, more so than it's like really hard or that it's going to be on the final and blah, blah, blah. Okay. So I'm going to try to incorporate as much as I can from our discussions in class, but this is all about finance and all about how when you invest that your money will grow exponentially, assuming it doesn't tank or something like that. But let's talk about all your finances. We're going to start off with some things that you are familiar with. So this compound interest formula should be a pretty familiar formula to you. It does have a remember so that you know this formula and how this works and what all the variables stand for. So here at the end is this is the amount that you have at the end of all of your investing. So at the end of whatever designated time slot, that's your ending amount. The P is the principal. Now remember that this used to be an A and it was always the initial value. Well, P is the same thing. It's just the principal is a banking term that tells you what your initial investment in the account was. So still the initial value. R is going to be your interest rate, but your interest rate is always written as a decimal. And when a bank advertises their interest rate, it's always the APR, the annual percentage rate. So because it's an annual rate, if you are looking at this investment like on a monthly basis, then you would have to take that interest rate and divide it by 12. Or if you were looking on a daily basis, then you would take that interest rate and divide it by 365 to see what the daily interest rate is. So this fraction right here indicates the interest rate for your period of time. So N is the number of times it's going to get compounded annually. So you take your interest rate and divide by that. This exponent up here is telling you how many times it's going to get compounded. So that means how many times per year times how many years. So if you did it monthly, so you did it 12 times a year for 10 years, then this would be 120. And I guess we better talk about real quick about what compounding it means. So to compound your interest means that you have invested in this account and the bank is going to pay you a certain amount of interest. And when they compound it, that means they actually calculate your interest and then they put it into your account. That's compounding it, because what happens is then you are gaining interest on your interest because they've built up the balance in your account with that interest that they added in there. So you want to do that as much as you can because you're gaining interest on the interest, and that's not really even your money that you had to put in. All right, let's do a couple problems using that formula. All right, so my first example here, how long will it take to turn $4,000 into $5,000 at 8% compounded quarterly? All right, so just filling in all the values for the variables. The ending amount is going to be 5,000. Your principal is your initial investment, which would be 4,000. One plus your interest rate is a 0.08. That's an annual rate. You're compounding quarterly, so I'll have to take it and divide it by 4. And then how many times am I going to compound it? Well, that's 4 times a year. And the whole question is, for how many years? How long will it take? All right. So I've already done all the math on my calculator to kind of hurry us along. For right now, you can just write my numbers with me. In a minute, I'm going to want you grabbing your calculator out and doing it on your own. But for now, I'm going to divide by 4,000. That's going to come out as a nice 1.25. I can actually calculate inside of here. 0.08 divided by 4 would be 0.02 plus the 1. So that's just a 1.02 to the 4t power. So ready to switch to a logarithm. Log base 1.02 of the 1.25 equals 4t. So now I can just type that in my calculator. I'm just going to use that alpha math, because I have a weird base here, and then take that value and divide it by 4. And what I ended up with was a 2.82 years. So that's not too long. An 8% interest rate is a pretty good rate. Okie doke. So let's try another problem. I'm going to look for something different this time. Now, this is a totally different problem, has nothing to do with the 4,000, 5,000 stuff. The question is, what interest rate will double my investment in 10 years, compounding monthly? Okay, so a little fun fact is that it does not matter if you're trying to take $100 and turn it into 200, or 1 million and turn it into 2 million. It's going to take you the same amount of time or the same rate. All of it's the same to double your money. So the more you have to double, the better off you are. So when I'm setting this problem up, I don't really know what my beginning and ending amount is. I'm just trying to double it. I could make up some fake numbers. I could put in a 100 and a 200. I'll show you here in a second. I'm going to jump over here to the parentheses. It's going to be a 1 plus. The question is, what interest rate will make this happen? And I'm going to compound it monthly, so I'll divide by 12. And then my exponent, the number of times it'll get compounded, is 12 times 10 years. So if I don't really know what I'm putting in, I could put in a P. And if I'm trying to double my money, then I would end up at 2P. Or I could put a 100 and a 200. Either way, the very first thing I'm going to do is divide by that P value, and it's going to go away. And so regardless of my number, I'm going to end up with a 2 here. And this is just going to be 1 plus r over 12 to the 120th. Now I'm ready to take the 120th root. That is in your calculator on math number 5. And that comes out as a 1.006. I'm just rounding as I write this, but I will always use full values as I calculate them in my calculator. Okay, so from there, I'm going to subtract the 1. I'm going to multiply by the 12, and I get R to be 0.0695. Now remember, that's a percentage, so the bank would probably advertise that as a 6.95% interest rate. And that would double my money in 10 years. All right, so a 6.95 if you were really investing. Remember, we're talking about your life here today. I'm going to keep throwing this little tidbits of information at you. 6.95 is probably a low percent rate in the investment world. And so you'd hope for something a little bit higher. And they say that you should be able to double your money every 7 years. So that sort of makes sense to me, because this is a little bit lower than even what we were having over here. That's why it took me a little bit more than 7 years. It took me 10 years to double my money. Okay, so that compound interest, that idea of compounding monthly or quarterly or something, there's certain investments that will do that, but probably just for your basic savings account, it's not as though there's some guy in the back room, actually computing this and then figuring out how much to put into your account. This is all done on a computer, so we don't really have to wait to do that once a month. It can oftentimes just be computed continuously, meaning as soon as you have earned 1 cent of interest, they're going to put it right into your account. So what that means is that it's getting compounded more and more and more and more often. So on that previous formula, as you increase that in value and make that larger and larger, it kind of works towards this new formula that involves an E. Remember how that kind of happens naturally in some of our situations. So here's that situation, compounded continuously. You still have your ending amount, still have your initial, but instead of the whole parentheses thing, it's just E to the RT. And the R is the annual percentage rate. Okay, this one says, how much do I need to invest at 6% when my son is born, if I hope to have $20,000 when he graduates at 18. Okay, so again, I'm trying to mix these up and make you solve for different things. So I know that the ending amount that I want to have is $20,000. And what I'm searching for is how much I have to invest. So that's going to be the P, the principal. And then what I've got is E2, the interest rate is 0.06, and I'm going to do that for 18 years. Okay, so really this is a pretty straightforward one because this is all just something I can enter into my calculator, and then I'll divide it over to the other side, and I'll have P figured out. So when you type that in, like I said, I've already done all the grunt work for us. Oops, not equals. Times, it gets us a 2.94. Divide that, and your principal is $6,791. And, ooh, I'm not sure if this is rounded correctly. My bad. I just put 0.9, but it is money. And so that was too long ago. I don't have that. So I'm just going to leave it 90, but that might be wrong. And then put a dollar sign on it. Okay, there you go. Now, all of that stuff is the stuff you probably already knew how to do. Let's talk about some new stuff. Okay, here we go. We're going to do some new stuff. And this is kind of cool because this really is kind of the way you would look at investing and saving money for your future. You know, you're probably not going to just put your money into a savings account and hope for the best there because your savings account is not going to get you a very good interest rate. So, and an annuity is a way to save kind of in a bigger way where you not just don't just put money in and then just sit and wait. You actually continually put money into an annuity. An annuity would be like a 401k. You've probably heard of a 401k. That just means like every paycheck you're putting a certain amount of money into this. And so not only is it earning interest, but it's also building because you're putting more money in. And as you put more money in, you're going to gain more in interest. So here we go. This is the formula for an annuity. It's called the future value of an annuity. And the FV means what is the future value going to be? Okay. R is going to be your regular payment. And then you have this 1 plus I, and I is also down here. So I is the interest rate per payment period. Now, previously they gave you in the formula that, hey, you got to divide that by N, but this is a messy enough formula on its own that they just expect you to recognize that this I is per payment period. So you will have to take your interest rate and still divide it by 12 or divide it by 4, whatever it might be. And that's what the I value is. N is the number of payments that you're going to make over the long haul. So again, they previously kind of worked this out for you. Now you just need to recognize, all right, if you're going to make monthly payments for 20 years, you got to figure out how many payments that would be. And that's what N is equal to. All right. And then you got this -1, big messy formula here. All right, I will give this formula to you. You do need to know how to use it, though. You need to understand what all the variables stand for and what you would plug into those. Now, this is the time I was talking about. You've got to practice doing this on your own with your calculator. Don't just trust me. It is shocking how many people, I mean, we can sit there and do it as a class, and maybe a third of us will get different numbers than everybody else. Maybe 2/3, who knows? It's a messy formula. You need to practice typing the numbers in and being familiar with how to use the formula. So that's my hint. Stop the video and go grab that calculator if you don't have it. All right, so we're going to look at a couple situations. I'm going to do situation 1 with you, and then I'm going to have you try situation 2 on your own. Okay, so here we go. Situation 1. You're age 25 and you kind of got your big boy job, big girl job. And so now you start deciding you're going to start saving for your future. So you start putting $100 a month into an annuity at 10%. Okay. And 10% is a pretty good interest rate there. How much money would you have when you retire at 65? Okay, I don't have a whole lot of space here to write, but that's okay because I have a blank slide on the next slide that you can work through this. And in class, what I did is I split everybody up, and half of them did situation 1, the other half did situation 2. But you kind of need to, because you're watching this on your own, you need to try 1 with me, try 1 on your own. So situation 1, I'm going to squeeze it in right here. Just looking through the formula, future value. That's what I'm looking for. How much money will I have? My regular payment is $100. So I'm looking for the future value is $100. Big fraction. You're just multiplying that. Okay. And then you have a 1 plus. Now your interest rate. Your interest rate is 10%. But because you are making monthly payments here, you have to figure out what the monthly interest rate is. So I am going to take the 10%, which is 0.10, and I'm going to divide it by 12. I am going to end up using this number so much that I am going to store it. So let's practice doing that on your calculator. You are going to type in 0.10 and then take it and divide it by 12. And I'm just looking at what my work says. It doesn't come out nice. It's a repeating decimal of some sort. And so then you're going to have to store that. So you're going to hit store, which is left of the 1 key. It looks like this, STO. And then you're going to store it in a letter. We're going to call it alpha. So hit the alpha key. And you can store it in alpha I. That happens to be the X squared button. So hit your X squared button and then press enter. And that means that whole decimal value is going to be stored under I. And the next, every time I need to use an I, I'm going to just hit alpha I, and that full value will pop up. All right, so here I go. So then I'm just going to write alpha, or I can just write I, or I can put the decimal for what it is, just a few decimal places if I want there. Okay, N is the number of payments. All right, so now I have to think about this. I started at 25 and I ended at 65. So I did this for 40 years, 12 times a year for 40 years. I'm going to go ahead and write this so you have it in your notes where this came from, but it's basically 12 times 40. And then I have a -1. And this is all over I. I'm doing a capital I just because your calculator makes it a capital, but you could use a lowercase I. I usually do, honestly. But okay, so now the trick is everybody getting the same number here. Different people do this differently. Some people like to, if your calculator is really nice and does that math print where you can make it look exactly like this with the fraction and all the exponents and stuff, some people like that. I'm more of a step-by-step, do it in stages on my calculator, so that's what I'm going to do. Let's see if we can get the same thing. So I kind of want to think about my order of operations as I do it. So in my calculator, I'm going to do this part first. I'm going to do 1 plus I. And then I would probably just hit enter. I could do the parentheses and then raise it to the power. And I know 12 times 40 is 480. So then I'm going to take it to the 480th power. You should be doing this on your calculator. And then I could press enter, subtract the 1. And at that point, I have the entire numerator. And then I'm going to divide it by alpha I. And then I'm going to take it times 100. And hopefully, the number you get is, future value is $632,408. I'm just rounding off to the whole number on these because we're talking big numbers here. So I don't care about 20 cents. All right, so that's what I got. All right, so now let's take a look at a different situation. So let's pretend maybe when you got that first real job, you got married, bought a house, had a few kids, and funds are tight. And so you don't really think about that investing until here we are at age 40. And now you're realizing, heck, that's around the corner. And so I better start saving. So to make up for that, you're going to put in $200 a month. And everything else is going to stay the same. So let's see. I'm going to have you do this one on your own. See if you can figure out how much money in this scenario, how much will you have at retirement? Okay, you're going to do this one on your own. So pause that video, come back and see if we can be in agreement. All right, so here's my number here. I ended up with $265,367. All right, what do you think? Is that anticlimactic, a little bit shocking that, oh, that $200 that I was paying extra did not make up for that at all? And even more interesting, let's take a look at how much money you paid into that. So I am going to go ahead. You have this extra slide, so I'm going to actually do both scenarios here because it's pretty quick and easy. Is in situation one, when I started at 25, and let's see, I was putting in $100, and I did that 480 times. Oops. So I ended up putting $48,000 in. The rest of that $600,000 was all interest that I earned. So, all right, so that's a lot of that. That was interest. But look at situation two. In situation two, you put in $200, and you did that. Let's see, that was the 25 times 12, and so you did that 300 times. So that ends up being $60,000. Look at that. In situation two, you put in more of your own money and still ended up dramatically less at the end. All right. So that's kind of an important thing to understand. What is the big difference between situation one and situation two? It's the time. Time is the key factor, because here's how this works. Money is going to grow exponentially, right? So it's going to look like this. And it's really on the tail end where it starts to make that turn, right? And starts increasing very rapidly. So if it doesn't matter, this could be at age 25 or this could be at age 40, but this is your starting spot right here. If you start here and only invest for 25 years, you've only made it to this level right here. But if you can invest for 40 years, now we're talking, because that's where it starts to kick in, is towards the end. So it's all about the time. You can't wait until you're 40. You've got to do this as soon as you get that first real job and you're making more money than you've ever made before you get used to having a whole bunch of extra money, before you go buying that fancy new car and new house and all the stuff. You go ahead and you automatically start pulling some money out of that savings account, or I'm sorry, out of that paycheck, and have it going into this annuity or this 401k before you get comfortable having it in your pocket, because we tend to spend it if we've got it in our pocket. All right, a couple other things, just life skills here I'm talking. Obviously, this is not set in stone. I had this set to where I'm putting $100 in a month. Okay, the reality is as you get older, you start making more money. Now you do start to have more expenses with kids and all the stuff in the house. So maybe you don't have money, but maybe you do. Maybe you're getting these great raises and you're making more. Maybe the kids have graduated and now you're at home and you've got more money. You are not tied to only putting $100 in or 200. You can keep increasing that, increasing to help that grow faster. So that's a good strategy. And honestly, what usually happens is, well, you can put up a flat amount, $100 or $200, but a lot of times what companies will have you do is put a certain percent of your paycheck in. So you might put in 4% of your paycheck. And so that will naturally grow as your paycheck grows through the years. So how much you're putting in will just naturally go up. All right. The other thing, one last thing that you have to be aware of, as you get into some bigger companies, they have some nice benefits. We've already talked about the insurance benefit a few weeks ago on how that is a big expense. So you want to be paying attention to that benefit option with your employer. But also, a lot of companies will do what they call a matching 401k. And a matching 401k is one where if you put in 4%, they will match that and they will put another 4% in for you that they're paying for. So that's like free money. You would always, always want to take advantage of whatever they're willing. They will usually cap that at some point where they're not going to match it forever. But whatever they are willing to match, you definitely want to take advantage of that full amount because that is just free money. Okay, there you go. Some life skills. All right, let's keep going. We're going to try one more here. We're going to be looking for something different on this one. This one's going to be a little bit trickier. I'm going to make you do a little bit of thinking, and I really would love for you to do your own numbers here. But you can do my numbers, but you have to decide for yourself. Okay, I had there's a commercial that I saw one time, and I videoed it because I liked it because it was this whole little thing about what's your number? How much money, your number is how much money do you want to have when you retire? Okay, so have you ever thought about that? Like, what is that number? How much money do you feel like you want to have before you're able to retire comfortably, live however you want to live? All right, so I want you to think about that for just a minute, not even a minute, like 10 seconds. Okay, you got a number? It's hard because you're not really paying bills. You don't really know what things cost. All right, I'm going to go with 3 million. Now, I feel like a 3 million for you would live very comfortably. You have a lot of years before you're going to retire. So your number would be different than what my number would be because I'm closer than you might think to that retirement age. So you can use 3 million with me. Maybe you're going to live in your parents' basement. You maybe need 200,000 and you're going to be just fine. Or maybe you have big dreams or anticipate a well-paying job and know that you're going to make some big money. And maybe you're a 10 million person. I don't know. Pick a number. The next thing we have to do is also decide is when is it that you want to retire? Because there's a couple things to think about here. It's going to take you a while to accumulate this. So you can't be crazy about, well, maybe you're going to like create some awesome new app or something and you're going to make a millions and millions in your 20s. That'd be awesome. Remember me when you do that. But you probably are going to have to, most of us will have to work until a decent retirement age, but you also don't want to sit there and work and work and work until you're dying and then you don't even get to use the money you've saved. So what age, okay, there's two ages here. You got to decide when is it that you think that you could start saving? What age are you going to start? And what age are you going to retire? Because we got to know how many years in there that this is going to happen, that you're going to accumulate this. So think about that. Come up with your two numbers. When are you going to start? When are you going to retire? Okay, I'm going to be a little bit more ambitious. I'm starting right out of college. I'm going to start at 22. And I am going to go until, I'm going to say 65. Okay, so what that would be then is if I'm going to retire at 65 and I'm going to start at 22, then what I have here is 43 years of working to accumulate this. Okay, does that seem scary? You're going to be working 43 years of your life? It's fine. Just find something you love. It's fine. Okay, here we go. Our job here is to figure out how much do we need to be saving? What does that regular payment need to be able to be at $3 million in 43 years? Now, I'm going to keep using my 3 million and my 43, but you can do yours. I'd rather you do yours so you have an idea of something that's going to be helpful to you. Let's go through this process. Here we go. The future value of my investment is going to be 3 million. I don't know what the regular payment is. That's what I'm trying to figure out so I can plan ahead. Then I have 1 plus. Oh, we need to know this. Okay. I'm going to say Just to make this a little bit different, maybe let's go a little bit lower. Let's make now, of course, interest rates will change through 43 years for sure, but let's pick out what we think it's going to average to. And just for no particular reason, I'm going to go with a 9%. Maybe it's going to average over the long haul. Now, remember, I am going to stick with my monthly payments here. And so I'm going to take my 9% and I'm going to divide it by 12. So 0.09 divided by 12. And then I'm going to store it in alpha I because I don't need that other I anymore. So store alpha I. Okie doke. So back to this. So 1 plus, and whatever that was, it actually comes out nicer than the 10 does, surprisingly, but that's okay. And now N is my number of payments I'm going to put into this. So that's 43 years times 12. So that's 516 payments I'm going to make. All right. And then minus 1 all over I. Now what I'm doing is I'm solving for this R. So what I see happening here is I'm going to compute all of this, and then I'm just going to divide it to the other side. All right. Are you ready? Okay, you can do your numbers if you have different ones. I'm going to go ahead and do mine. And if you did do mine, go ahead and right now together, we're going to put this in the calculator. I'm not going to talk. I'm just going to type it in. Let's see if we end up at the same place at the end. I didn't say it, but I should be saying it. You're always using full values. You're talking about 43 years here. Always keep full values as you go through that. That's why we're storing the I. Go up and grab as you need to. All right, here's what I got for mine. My regular payment, what I need to save every month is $486.43. That's what I need to save to get to 3 million. Okay. Now, hopefully you got the same thing. If you used my numbers, if you didn't, yours should make sense for comparison to what mine is. So if you were like the 10 million person, obviously your regular payment's going to be a lot more. If you were wanting to retire at 55, again, it's going to be a lot more. If you were going to work till you were 75, then it could be less. Now, this might be scary. I don't know. What do you think? Is that something that if you had that first real job that you would have an extra $486? Obviously you're going to have other bills too, but that's kind of the goal. Just so you need to do some planning, and either you have to adjust up here or whatever you got to do to make your dreams happen, I guess. All right. So something to think about as you move forward and choosing that career and what the future possibilities are for you. Okay, let's go ahead. Let's look at one more thing. We have one more formula. It's very similar to the future value of an annuity, but this one is called the present value of an annuity. So this is like how you determine payments on a loan. Okay, it was kind of fun story that I went and bought a new car, and I had just ironically had just taught this lesson. And I was thinking, I wonder if that really works like it's supposed to. And ironically, I went home and I had calculated what my payments on my loan for my car loan were going to be. And danged if I was not, I think I was off by 1 penny on it. So this is real deal. This is what they do. It's calculated as the present value, meaning what is your loan going to be for? That's the present value of it. This is going to be your regular payment. Notice this is kind of rearranged up here. And this is actually going to be exponential decay. See how the N value is a negative? Because the value of that loan is, or the balance of that loan is going to decrease as you pay it off. Okay, and the I, same old deal. You got to divide it out by how often you're making that payment. Let's do one example of this. Okay, tried to come up with a scenario that might make sense here for you. You're going to get this new car. It's going to cost $16,000, but you've been saving up. So you have $3,000 that you're going to put down up front. And then you're going to get this loan at 3.2% annual percentage rate, which is a decent percent for that. If you can afford a monthly payment of $235. So that's kind of what you've budgeted into for a car payment. How long of a loan do you need to get? So what do we need to stretch this out for so that you're able to afford it at the $235? Okay, here we go. Let's put in some numbers. Okay, what will be the present value of your loan? What are they going to give you that loan for? Okay, it is not $16,000 because remember, you saved up $3,000 to put down up front. So you don't need a $16,000 loan. You only need a $13,000 loan. Okay, so the present value is $13,000. Your regular payment is going to be $235. 1 minus 1 plus. Okay, now our interest rate is going to be this 0.032, and you're going to make monthly payments, so it's going to be divided by 12. You can store that because you know you're going to use it again later. All right, to the negative, and then this is kind of the question is, how long does this loan need to be for? Okay, it might feel like I'm doing a lot of these examples, but every time I've done it, I've had you find something different. So this time I'm looking for the exponent. So this is a different problem than the previous ones. Okay, I am going to go ahead and type in the 0.032, divide it by 12, and I'm going to store it in alpha I. Okay, so now trying to figure out how to compute this to isolate this in. So there's some stuff going on. I think I'm going to first divide by the 235, and then I'm going to have this left. And so then I'm going to go ahead and multiply by the I to get rid of this messy denominator. I'm going to do both of those things right now on my calculator. Divide by the 235, multiply by alpha I, and I am at 0.1475 right now. And what it's going to be equal to is this right here. And I'm going to go ahead and put an I since I went ahead and stored that. Okay, so now it looks like I want to subtract the 1. And when I subtract the 1, this is gone, but the negative is still there. So let's go ahead and divide by a -1 to get rid of the negative. So now all I have left is this. And what I have on my calculator now is a 0.852 is equal to 1 plus I to the negative n. And I am now ready to switch that to a logarithm. All right, I'm kind of running out of room, so I'm going to go this way a little bit. All right, so as a logarithm, it's going to be log base, and you can actually type in 1 plus I. I don't even have to go calculate it. That's what I'm going to type in my calculator. 1 plus I is my base of the 0.852 number, but I'm going to go grab it for full values, equals negative n. All right, so math, alpha math, go calculate that. And I got n to equal, go ahead and divide out the negative on it. N is equal to 59.93. Okay, but let's think about this for a second. All right, what would you label that right now? What does n represent? Okay, n is the number of payments. So don't you dare write 59 years. Good grief, you're going to pay for a car for 59 years. You're not even going to pay for a house that long. So 59 years would not be the correct answer. It's 59 payments, 59 monthly payments. So you have to divide that by 12 to figure out how many years. So divide by 12, and it comes out almost, well, not exact, but pretty darn close to exact, that it is going to take you 5 years to pay that off. You need the 5-year loan on this. If all you can afford is the 235, then you stretch it out. Okay, now, just out of curiosity, how much do you think that loan ended up costing you? You made 60 payments of $235. So I'm going to do 60 times 235. All right, that cost $14,100. So the bank charged you an extra 1,100 to borrow that money for 5 years. And so you have to decide, the quicker you can pay off your loan, the lower that interest will be that you'll end up having to pay. So it's all about, trying to pay as much here or make some extra payments if you come across some money. Maybe you get some birthday money, or maybe you got a bonus at work and you can pay a little bit extra to help hurry up paying off that loan. Okay, there you go. Some life skills today. What's the rule? What's the number one rule? Well, okay, there's been a lot of rules. My number one rule is, though, invest early. You have to invest early. You can't wait until you're 40. You can't make up for that time. That's the big trick. The time is the thing that matters. All right. Have a great day.